Okay, in today's class, we are especially focusing on integer, fraction, and decimal. I will cover these three topics today. And I have already told you that all, if you remember, if you could recall, in the number system, I have already told you that all natural numbers are the part of whole numbers. All whole numbers are the part of integer. That's we are starting today. All integers are parts of rational number, and there are some irrational number, and all rational number and irrational number together form the real number. This is called Venn diagram. We have a separate chapter, later on we will cover in our discussion. These two rational number, irrational number together form the real number, and this real number consider rational and irrational holistically, but under rational we have natural, whole and integer. And I want to tell you today that these natural, whole and integer don't include decimal and fraction, and that's the same thing I have written here. Integer include complete value. What is the meaning of complete value? It simply means it does not include fractional and decimal value.
Oh, it doesn't include fractional and decimal value.
Yeah, that is why we call it includes complete value. And if you say, if as you were saying like this, that is actually the part of real number that you were saying. Under real number from minus infinite to plus infinite, that is not under integer, that finite, that is not under integer, that comes under, because in mid we take, and towards left we take negative values like this, and towards right we take positive values definitely, and in mid we can also take, like we can also take 1.5 here, and we can also represent, you must have learnt or you will learn later on, there is way to represent even irrational number like root 2. We can even represent irrational number. That means in this number line, all real number has actually this definition. We have even gone through this definition earlier when we started the chapter. Under real number, actually we include all type of rational and irrational. This is the first point about real number. And second thing we say about real number is, real numbers are those numbers that can be represented on number line. All the numbers that can be represented on number line comes under real number. In this way we represent the real number. Okay, and when you say that you can represent all numbers, towards left there are negative, towards right there are positive, then you are actually talking about real number, not exactly integer. But if you represent only the complete value, like you are representing 0, that is neutral number, you are representing all these complete value towards left, all these complete value towards right. If you are representing complete value, then you will say you are representing integer. But if you are representing everything including decimal, including fraction, then you will say you have represented real number. And that's why we say all numbers that can be represented on number line are real number. And this definition I have already given you when we were discussing number from our basic classes. I think you must be okay with these definitions, and you can quickly make the proper notes of this, because here I have explained about real number. In this Venn diagram I have shown you that natural number, all whole number, all natural numbers are inside whole number. That means all natural number are whole number. Okay, all whole are inside integer. That means all whole are integer. Similarly, all integer are inside rational. That's why all integer are rational. And so on, all rational are real. Even all irrational are real. In this way, I have also explained you how to form different statements. Yeah, I think you must be able to recall it because we have discussed these concepts in previous classes. Today we are especially working on integer, fraction and decimal. Let's come to the integer again, and under integer we include these three type of complete value. I have already mentioned here that we do not include fraction as well as decimal in integers. Fraction are not included in integers, decimal values are not included in integer. Then question arises, where do we include them? These fraction will be included in, like natural number, whole number and integer will not include fraction. But here the gap you see, this gap will represent all p by q form, and that's why rational number will include even decimal and fraction. Then which number will include decimal and fraction? Which number will include fraction and decimal? Because today's topic is integer, fraction and decimal. That is why we need to learn what are included in integer and what are included in fraction and what are included in decimal. First I am telling you about integer, and that's why I said integer doesn't include fraction and decimal. They include all complete values, and those complete values are these values. We start with mid 0 and towards 1, minus 2, minus 3, they goes up to minus infinite. Towards right we have 1, 2, 3, 4 up to infinite, but don't include the mid values, like we don't include fraction or decimal between 1 and 2. We include only complete value. Then where do we include 0.5? Where do we include 1.1? Where do we include 0.3? Where do we include 1 over 2? 3. Where do we include 1 over 2? We include all these, and other values maybe in irrational number. We include those values, decimal values and fraction values, under rational and irrational. Understood? And that is why rational and irrational together form the real number. Under integer, that is z you represent, we represent it by z because there is a German letter Jahlen, we use it, that means to count, and because of this German word we use,
Actually not German.
yes.
Okay. Because I was just thinking, like, because we normally speak English, then no problem. I just want to know it.
Yeah, actually this word means figure, or numbers. This word is related with integer. It's a German word. From German word we have taken this first initiative z. We don't use I, rather we use z to represent integer. These integer may be negative integer, neutral integer or positive integer. Under negative integer we take negative of all the natural numbers. Under natural numbers we include counting numbers 1, 2, 3 and so on. Then we have neutral numbers, that is 0 itself is a neutral number. Only 0 is a neutral number. It is neither considered to be negative nor positive. I think you must be okay with the integer concept now. In our syllabus we are considering special three topics today: integer, then fraction and then decimal. These are the three topics in our syllabus. Integer never include fraction and decimal. Integer always include the complete value. If integer includes negative of the natural number, we call them negative integer. If it includes exactly 0, we call it neutral number. And if it includes all natural number, we call it positive integer. All natural number can be called by the name positive integer.
Oh, I understand.
Okay, then come to the fraction. The second topic we are supposed to discuss today is fraction. Let's come to the second topic. I will first tell you about these three topics, then we will start solving some questions. Let's come to the fraction. Because integer doesn't include fraction, then which number is going to include fraction? The answer to this is rational number includes fraction. The answer to this is rational number include fraction. Because rational number include all those number that can be written as p over q. That is why rational number include fraction. And the exact definition of rational number is q can't be 0 and p and q are integer. Yes, this is the definition of your rational number. And under this rational number you can get two type of decimal. Actually, for this rational number we can define all these rational number of the fraction type, of the p by q type. Like if I take example, if I take 1 over 2, what do you think? Is it rational? 1 over 2, that means if you have complete 1, you are taking 1 over 2. 1 over 2 indicates, that means you are dividing 1 into 2 parts. You are dividing 1 into 2 parts. Then the upper part is called 1 over 2 and lower part is also called 1 over 2.
It's half. 1 by 2 is half.
It's simply half. It indicates that you are dividing whole into 2 parts. Similarly, you can have 2 over 3. Can you tell me the meaning of 2 over 3? 2 over 3. If you want to represent 2 over 3, you can draw a circle and you can divide this circle into 3 equal parts, making 120 degree each. Then this portion represent 1/3. This portion represent 1/3. This portion also represent 1/3. Then how will you represent 2/3? The answer is you take 2 1/3 together. If you take 2 1/3 together, this yellowish region then represent 2/3. Got it?
Oh, like that. So that's how it works.
Yeah, that's how it works. Yeah, exactly.
Oh, I'll just note it down.
Yeah, you note down these concepts. And not only this, there are many other concepts that you can note down. I'm presenting them here. 4/5. Then what can be the exact way to represent 4/5? You can draw a pentagon. Drawing a regular pentagon will be an exact way to represent 4/5. And here if you join them all, then each region represent 1/5. Each region represent 1/5 because there are 5 equal portion. Each region, total 5 region. If each region represent 5, then 5 region represent 1. Okay. Now if you want 4/5, you will take 4/5, you will shade 4 portion. You will shade 4 portion like I'm doing now. Then this shading will represent this 4/5. Similarly, if I ask you to represent 5 over 6th, region 5 over 6th.
Okay.
How will you represent the region 5 over 6? Here you have to draw the hexagon.
Hexagon.
Yeah, hexagon. If you draw the hexagon, that is a regular hexagon. It means all of its sides are equal. And if you join all of the vertices with center, you will get an interior angle which is